In the first part, I will show you how to use multiple regression to investigate the impact of relationship equity on company performance. Relationship equity including customers' trust, customers' satisfaction, and customer attitude, and company performance in the marketing context, including customer loyalty and customer word of mouth. And both independent variables and dependent variables are continuous variables. Now let's start with our R script. We need to load several required packages, including tidyverse, psych, and ggplot2, right? Let's run the codes. As I mentioned in the previous videos, when you check the b-values, usually the b-value will be expressed in a scientific notation, and it might be brilliant to remove this scientific notation and just see decimal places of p-value, so it's easier for interpretation. Let's run it. And very important, we need to open the data file, right? So let's run the code read CSV and choose the data set. Right. So let's check the column names of the data set. So we have 9 columns: ID, gender, age, vanity, trust, satisfaction, word of mouth, loyalty, gratitude. Now let's check some basic statistics of our data. All right, if you look at these summaries, what do you know about trust, satisfaction, word of mouth, loyalty, and gratitude? These variables are measured on Likert scale from 1 to 7, right? 1 to 7. Now, let's go further and check more detailed descriptive statistics of these variables. All right. So if you look at these continuous variables, you also see the mean, the number of observations, the range. But there are two things I would like you to focus this time. That is the skewness and kurtosis. So the skewness quantify how much a distribution leans to the left or right relative to a normal distribution. So right here we have almost all negative skewness, and negative skewness or left skewed. It means the tail is longer on the left side and most data values are concentrated on the right. And another index called kurtosis. And kurtosis measure whether the data have heavy tails with a lot of outlier or light tails compared to a typical normal distribution. In this case, we have all the kurtosis index smaller than 3. So it means that the distribution of these variables have light tails with fewer extreme outlier. Right. And also based on the summary, we know that we have the variable vanity. And these variables are measured as a categorical variable with 0 means customer will not be charged for the late checkout fee. And 1 means customer will pay the penalty fee. And in the current form, this variable is numeric, and we need to convert this variable to factor or to categorical for further analysis later on. All right, so right here, we would like to convert the penalty variable to factor. What do you think we should fill here? So we already used the function as the factor many times. Basically, we just call the column name. And the column name is penalty, right? Okay. So we can type the data frame that we store the data, which is df, right? And with $sign and choose penalty, right? And let's run the code. Excellent. So right here you see the penalty variable has been converted into 0 and 1, two levels. All right. Now, before we run multiple regressions, we would like to check the relationship visually. All right, and how to do that? We can use the scatter plot. The scatter plot is one way we can see the relationship between two continuous variables. If we use the base R scatter plot code plot right here, we can see the scatter plot of all continuous variable, in particular those column 5 to 9, right? 5 to 9, right? Now we can zoom in and we can check the scatter plots we have right now potentially show relationship between two continuous variable. For instance, right here, you will see the relationship between trust and satisfaction. They have a potential linear correlated with each other. In the previous scatter plot, when we use the base R, you can see it's a little bit messy. It's a lot, right? So how about we try a general function and we apply that function for every single relationship between two continuous variables. So right here, we are writing a function to create a scatter plot with ggplot2. All right, so please bear with me. So in this line, basically, we are trying to define the function that we want, and this function needs three inputs: the x variable, the y variable, and the data, right? This line will map the value of x variable to x-axis, the y variable to the y-axis. That's it. And this line will add the data point based on the coordinates of x and y. And this line will help us to avoid the points overlapping, like this one, right? Good. The next code will help us to create a potential linear relationship lines to represent the potential relationship between two variables. And the last code basically just add the title for the plot. Right. Don't forget to run the code. Good. Now, you already have the general function to create the scatter plot already. And we save that function in an object called scatterplot, right? Now, we just use that function and just add specific input, particular, what is x variable, what is y variable, and what data we need. In particular, right here, we would like to create a scatter plot for the relationship between trust and loyalty. So, what is x and what is y? If you look at our research framework right here on the screen right now, you will see trust is x variable and y is loyalty. So we just add trust as x variable and loyalty as y variable, right? And let's run it. Good. So right here you see we have much better scatter plot to show the relationship between trust and loyalty, right? But not only creating the scatter plot, you need to understand what does it mean. So basically, you see the positive correlation between these two continuous variables, right? So if customer trust the company more, they probably stay longer with the company, right? We have very dense area right here in the top right corner of the plot. It shows that the majority of customers have both high trust and high loyalty, right? How about these special case? So they are outlier, right? So they are very interesting to be investigated. Why those customer they have very low trust, but they stay very long with the company, and vice versa for this customer. That could be an interesting question for you to investigate. Right. So definitely you can apply the same mechanism for the other scatter plot between sufficient loyalty, between sufficient word of mouth, between gratitude and word of mouth. Right. And it's time for us to run the multiple regression analysis, right? All right, so remember, in R to specify the formula for linear model, you use dependent variable tilde sign and all the independent variables. In particular, right here, we would like to examine how trust, satisfaction, and gratitude affect the dependent variable loyalty. All right, we will run the linear model and save the result in red loyalty. So right here, we specify loyalty as dependent variable, trust, the first independent variable, satisfaction as second dependent variable, and gratitude as the last independent variable, and the data is df, right? Good. Now we can run the code. All right, excellent. So we have the result for multiple regressions right here. Of course, you can check the b values, so you can see all the independent variables are significant. All right, but let's look at some other index as well. So residuals. So the residual represents the difference between the actual and predicted values of dependent variable loyalty. So you can see the residuals here are very small and center around 0, which is a good sign that the model is fitting well. And you also have the coefficients, right? Each coefficient represents a change in loyalty for a 1 unit increase in the predictor variables, holding other variable constant. All right. So for instance, for a 1 unit increased in satisfaction variable, holding other variable constant, the change in loyalty will be 0.58. All right. And again, all predictors are statistically significant at b smaller than 0.01, meaning the impact are real, right? And another index you can look at is the multiple R-square. So the R-square right here is 91%. It means the variation is planned in loyalty by 3 independent variable trust, satisfaction, and gratitude is good. This is high value, meaning we have a strong model. Overall, the model is highly predictive, with satisfaction being the strongest driver of loyalty, followed by gratitude and trust. Right? Great. So once you practice, try yourself with the second multiple regression to check the relationship between trust, satisfaction, gratitude on the word map. All right, in the second part, I will show you how to check the effect of marketing strategy on both relationship equity and company performance. In particular, we will check what is the effect of the penalty fee on trust, satisfaction, gratitude, loyalty, and word of mouth. And penalty here is the grouping or categorical independent variable, and all 5 dependent variables are continuous. And today, I will use ANOVA. Great. So based on the model we just see, if we drive the code for every single relationship between penalty on one specific dependent variable, we will write very long code for ANOVA, as well as we also need to check the mean difference between different groups of the grouping variable. So instead of doing that, we can write general function to compute the mean of different groups and to perform ANOVA, and then use these 2 general functions to apply for a single relationship, right? Let's do it. All right, so right here, we are going to write general function to compute the means and standard deviation for different groups. All right, again, the first line, basically we define the function that we want. The function we want needs the input of dependent variable, of the grouping variables, and the data. And then based on the data, we will group by the data by the grouping variables, right? And then we tell R to summarize how many observations we have in each group. We compute the mean of dependent variables. For each group, we compute the standard deviation of the dependent variable for each group, right? And we also have the general function to perform ANOVA, all right? So again, in the previous week, we have conducted a lot of ANOVA tests and t-tests, and feel free to check the previous videos on ANOVA tests and especially how to interpret the ANOVA result, right? Good. All right, so don't forget to run the general function. And after that, everything easy, right? We already have the general function on computing the mean on ANOVA test. Now we just use these 2 general functions to check the relationship that we want. Now let's start with this one. We want to check the effect of penalty on loyalty. Okay, if you look at the research model, so penalty is the grouping variable and loyalty is the continuous variable. And based on how we define the function of compute the mean, we see in the first place, we need dependent variable, which is loyalty. And in the second place, we need the grouping variable, which is penalty, right? Right, good. Now, please look at this result. How do you understand it? We have 2 groups of penalty, 0 and 1. 0 mean customer will not be charged for the late fee, right? And 1, yes, customer will be charged for the late fee. All right, so we have equal size for each group, right? 138 and 139, almost equal. And the mean value for group 0 is 6.28. The mean value for group 1 is 4.17. So obviously, the customer without the penalty will stay longer or more loyal to the company, right? So right here, based on this result, we just know the mean difference. But we need to do the second step, which is ANOVA, to check if this difference is significant or not, right? And we already have a general function right here, which is ANOVA test. Now we just add the input for the function, which is what is dependent variable, what is independent variable, and what is the data. That's it. And exactly the same in the first place, we need loyalty, which is the dependent variable. And in the second place, we need penalty. Excellent. And let's run the code. Good. So the result tells us that, yes, the difference between 2 penalty group 0 and 1 is significant as 0.001. And please, again, it's very important to understand the results in the marketing context. All right, and I think you are more capable to replicate the analysis for the other relationships in the research model. In this video, we are going to discuss the response model, which is a statistical model that captures the relationship between the past marketing efforts and the past company outcome. Right. In particular, for the case today, we try to investigate the relationship between the marketing efforts for four locations, location 1, 2, 3, and 4, and the company revenue. And at the same time, we also take into account the time factor. Basically, this time factor will consider the natural decline trend in revenue that come from competition, that come from the market change. Let's load the required package. Good. And remember, we use this function quite a few times. We try to see the values in normal format and prevent the scientific notation, which makes our interpretation a little bit easier. So let's run the code. All right, next, let's open our data file and save it in a data frame called df. If you successfully load the data file, you will see we have 60 observations with 6 variables. Now let's check the column names of our dataset. So we have 6 columns: revenue, location 1, location 2, location 3, location 4, and the train. All right, next, let's summarize some basic stats for all the columns in the dataset. All right, so if you look at this one, in the first line, you will see the scale for revenue, the first location spending, the second location spending, the third location spending, and the last location spending is in terms of money, right? In particular, we have the trend column, which range from 1 to 60. What does it mean? Basically, in this case, the company collected data over 5 years, and 1 to 60 means 1 to 16 months. So the time will be counted monthly. That's it. Now let's have a look at the data set. So you see all the columns are in monetary values. And for the trend, we have 1 to 16 months. Right. Before we do something officially for response model, let's see how the revenue trend looks like over the last 5 years or over the last 16 months. Okay, so let's use ggplot to plot the trend. In the first line, basically we use the data from df and we want to map the value of the trend to the x-axis, right? And we want to map the value of revenue to the y-axis. So we type revenue rate. Great. If you look at this trend plot, you will see overallly the company revenue declined over the last 60 months. All right, come back to the theory. The response model is quite similar as the linear regression model. The only difference is the inputs and the outputs are converted to log values, right? Good. So let's convert the relevant variables to log values. Okay. All right, right here. Basically, we just convert each column to log value. So in the first line, we want to convert the revenue column to log value of revenue. And I just use the same name of the column and paste it here. All right. And let's do the same for the second column, which is the spending for the first location. Right. This is the spending for the second location. This is the spending for the third location. This is the spending for the fourth location. Great. Now, I suggest you run all the code at one time. Do you know why? Because if we run each line more than once, we will compute the log of the log. For instance, okay, if I run this code one time, yes, we compute the log of revenue column. But if we run it one more time, then we will compute the log of revenue, right? Right. And now let's check the data frame. This is how it's look like after we converted all the variables to log values. Great. Now, everything the same as it is in the linear regression model. So right here, what do you think? How we specify the regression model? Remember, if the data frame look like this one, we have the outcome variable in the first column and the rest are the independent variables. Then we can specify the outcome revenues, to the side, and that. And we can run the model already. Great. So we save the model result in the object fit. And if we want to see the result of the model, we can summarize fit. Great. Very good. All right, so we have the result from our model. So let's try to interpret the meaning of the coefficient, given that we know that all independent variables here are significant. All right, so let's try to interpret the meaning of the spending for the first location. What does it mean, 0.34? All right, it means that 1% change in the marketing effort for the first location will lead to 0.34% increase in the revenue because this is the positive coefficient, right? And please try to interpret the meaning for the other coefficients for other locations marketing efforts. The only thing I would like you to focus and challenge yourself how to interpret the meaning of this coefficient. Remember, we didn't convert the trend column to log value. It means that 1 month forward, the revenue of the company will decrease by 0.001%. And this interpretation aligns with what we see on this revenue trend over time, right? Good. Now we already have the result model. Okay, all of this we call the result model. We would like to extract the estimate from this result model. Okay, and for now we use the tidy function. The tidy function can help us to extract the estimate from the regression model beautifully. In particular, we already saved the result model in the fit object. We just tidy the fit object. That's it. And we would like to tell R to round all the estimates and keep all of them with 2 decimal places, right? So we would like to have 2 decimal places right here. Now let's run the code. Good. And let's print the estimate data we just created. Very good. Okay. Actually, this estimate data frame is the same as what you see in the model result, right? It just look neater and more presentable. Great. All right. So from the response model, we already know the coefficient for each location, right? So then, as a marketing manager, how would you allocate the resources? All right. The idea is we just take the coefficient of each location divided by the total coefficient of all four locations. That's it. For instance, for location 1, we take beta 1 divided by beta 1 plus beta 2 plus beta 3 plus beta 4. And the same thing for other locations. That is the mechanism how we allocate the resources. Great. All right, having said that, having the coefficient for four locations is important. Now, let's do one step further. Let's extract the coefficients for four locations only. All right. So right here, let me show you how I proceed with the code. Okay. So if you use the code summary fit, so basically you got the whole model result, right? What happened if you add a dollar sign and you call coefficients? In that case, then you will get all estimates, right? Like this one. And we only want the coefficient, and the coefficient is the first column in this table or in this data frame. All right. And we can specify. Okay, so this is what we want for the first line of codes right here. So in the first blank, basically that is the fit. And this is the coefficient. Great. And the next line, basically we sum all coefficients belonging to four locations, right? So, so basically we only take into account this one, this one, this one, and this one. Right. Now we're almost done. Okay. So the next step, basically, we try to compute the proportion of each location's coefficients over all coefficients together, right? So right here, I use a new function called turbo, okay, to compute the proportion of each location. In particular, in this code, in the first column, I create a vector called location. It stores the name of four location. That's it. Okay. And the next line, basically, I compute the percentage of coefficients for each location. So we take the coefficient of each location divided by the total or the sum of all coefficients, which we already computed right here. Okay. So it is blank. It is total. Now we can run the code already. Good. And we can print the allocation data frame that we just created. Right? You see, the first column we have location. We store the name of four location. The second column we have percentage. We store the resource percentage for each locations. All right. Now we can go one step further to plot the resource percentage for each location. All right. I give you some hints right here. You can use the hint to prepare the ggplot, the bar plot. All right. So in the first blank, basically, we need to specify what is the data set. And the data set we want to use is allocation, right? And on the x-axis, we want to see the names of location. So we want to map the location value to x-axis, which is location, right? And on the y-axis, we want to see the percentage for locations. So we want to map the percentage column to y-axis. Right. The next blank, what do you think? Field. Basically, we want to color each location by a different color. That's it. And we will use the value from location for it. Right? In the next line, basically, we want to tell R that we want a bar plot. That's it. All right. In the next line, we want to tell R that please add the label for each bar of the location using the percentage value. For instance, for the first location, I want to see the resource percentage, which is 38.7. So right here, we would like to tell R use the value from the percentage column, right? And the next code, basically, we want to add the title. Now we can run already. It. All right, great. So of course, we should use the power of ggplot to present our findings in the marketing context. All right. So as a marketing manager, you should analyze why you should spend that much for the first location and vice versa, why you should spend that little for the last location. Today we are discussing how to run sentiment analysis and topic modeling in R. So first, we need to install all the required packages, and then we load them into our R environments. All right. So it might take a while. Next, we can choose a random seed to fix any randomness that might happen in our text mining process, and you can choose any random number that you want. Now let's load the data set. And if you load the data set correctly, you will see we have 500 observations with 3 variables. Now let's look at the data set. The first column is the ID column. The second column is the rating. And the last column is the reviewed or the comments from the customer. And if we look at the data, we see that we might have a few missing values for the last column. All right. So some reviews may have strange symbols or unreadable text due to encoding issues. That's what we need to make to ensure all the text is properly formatted. So if you are the Mac user, you can run this line of code. And if you are the Windows user, you can run this one of code. So let me run this one, right? And then, as I just mentioned, we have a few missing values, and this live code will help us to remove those missing value. Great. Now we can check how many observations remained. So originally we have 500 observations, and now it's reduced down to 434. Great. Now let's move on to the pre-processing text. So it's time for us to convert all the reviews or comments into a text corpus. What is it? A corpus is a collection of text data, and this process will treat each review as a separate text document. All right, so let's run the code. Good. We also need to clean the data a little bit better. For instance, we need to convert all the character to lowercase. We need to remove the punctuation marks. We need to remove unnecessary numbers. We need to remove common stop words such as articles, conjunctions, pronouns, etc. And we also need to remove the extra spaces. And very important, we need to reduce the words to the root forms or apply stemming. For instance, the word running becomes runs. So these removal are necessary to make sure that we only keep the necessary content for the sentiment analysis and topic modeling. So let's run these at once. Great. Now we are ready for sentiment analysis. So we only need to use the function getSentiments with the default method, and we apply the clean text above to this function. And that's it. Now we can add the sentiment score to the original data, right? So we can open the DF now. You see we have a new column. Basically, this one is the sentiment score. And how interpret it? So if the score is positive, it is a positive review. If the score is negative, it is a negative review. And if the score is around 0, it is neutral. As I mentioned, we might have 3 categories: positive, negative, and neutral reviews. So the next live code will help us to categorize the sentiments into 3 categories. Basically, we just use if-else function. All right. So there's a note that the 0.2 cutoff here is randomly chosen here to avoid labeling slightly positive or negative value as a very strongly positive or negative. That's the goal of the cutoff. Of course, you can choose a little bit different cutoff like 0.1 if you can justify the practice. Now let's visualize the sentiment distribution based on the sentiment score. So we use the ggplot, which we already used a lot in the previous sessions. So let's run the code, right? Or another bar chart as well. So this one could be a little bit easier to interpret. So what do you see right here? So majority of customers are quite positive about our product and services. Good. All right. So remember what we discussed in the lecture, how we compute the sentiment score. All right. So basically that is computed by the percentage of the positive word and the negative word overall, the total words, right? But of course, because we are using the top-down approach, sentiment analysis, we need to use the existing dictionary, and each existing dictionary will have different scales. So let me demonstrate to you, okay, how this package compute the sentiment score. So for instance, I have a text inline marketing analytics module, but the coding is hard. So I just use the same function and I compute the sentiment score. And you see the sentiment score here is 0.25. How I get that? So you see we have a positive word here is like, and the negative word here is hard. So I will compute these words separately. So for the like word, the score is 0.5. And for the hard word, the score is minus 0.25. And it makes sense. The total score for the whole sentence is 0.25. The other words are neither positive nor negative. All right, now I will change the text a little bit as you can see, I do not like marketing analytics module because the coding is hard and we use the same function. All right, so let's check what is the sentiment score. So the sentiment score is still 0.25. What do you think? We have a negation word here, not, but the same score, like the score for the first text. Does it make sense? So basically, this example shows us that the package that we are using has some limitation. It does not consider the negated words like not. Okay, and many sentiment analysis dictionaries will only assign the scores to those words that have intrinsic sentiments. In our example, that is positive. Negation words like not, never, no, isn't, versions are typically not assigned scores because they do not carry sentiment by themselves. So if we have some words like not good, good will get a positive score, but not does not affect it. So there are some ways to handle this situation. So you can pre-process the negation manually and manually add those new dictionary words to the sentiment lexicons with a negative score. For instance, you can add a new dictionary word like not good equals to bad. All right. But at the same time, you also need to think. So in each review, the volume of text is a lot. So it might be to some certain extent will balance the impact of the negation words as we just discussed. Right. Now let's move on to a second part where we discuss how to run the topic modeling. So one thing we need to do is, because we try to do the topic modeling in the context of hospitability for Airbnb. So maybe when customer wrote the review, they mentioned Airbnb or they mentioned the location that they rented the property for, like Paris a lot. So we don't need those kinds of words in the text, and we can remove those custom stop words. All right. The next step, we continue to clean the text a little bit further and break all the sentences into individual words or terms by using the function text processor, right? And in this function, basically we are to process all the comments in the DF data frame and use other columns in the same data frame as a metadata. And please remove the custom stop words that we specified above. That's it. And now let's run the code. Right. So a very important step is to prepare a document term matrix. DTM, what is it? DTM is a structured representation of text data that shows the frequency of terms or words appearing in a collection of documents. And it is widely used in natural language processing and text analysis. How a DTM looks like. So the rows represent for documents or the review, and the column represent for the unique terms or words. And all the cells value indicate the frequency of a term in a given document. The next step, we try to convert the processed text into a structure document term matrix format with the list of the words used in the model and the associated metadata, in particular, this case, that is rating. All right. And then we extract these three components, the documents, the vocabulary, and the meta. Just be ready for the following analysis, right? So let's run the codes right here. Good. Now, next, we need to use the structural topic model, STM. STM basically very similar to regression analysis. It is a method used to find the hidden themes or topics in a large text. It's powerful because it can connect the topic to external factors. In particular, in this case, we try to connect the topics to the rating data. And it can handle very complex data. That is the strength of this method. Now, let's analyze how we specify the STM model using STM function. First, we need to tell the function to use the process text reviewed in the document term format, right? And we also need to input the list of the words used in the model after filtering the stop words specified. All right. So we can set the number of topics that we want. For instance, in this case, let's set the k equal to 10. But if you want to let the algorithm automatically choose the number of topics, you can set k equal to 0. But because of the time constraint, I will set it k equal to 10, right? And right here we have prevalence equal to tilde sign rating. So basically this part tell R to use the rating metadata to analyze the topic trends across high versus low rating. It's very similar how we specify the regression analysis. Remember, DV, tilde sign, all the IVs. Additional data besides the comments, beside the reviews. Good. And the last line of code, basically, we want to specify the function to use the special clustering method for topics analyzing, which is very special clustering analysis for text. Good. And also, it's very similar to regression analysis. After we run the STM model, we should check what is the weight or what is the relationship between the topic and the rating. So first, we need to convert the rating column into a categorical factor variable. And then we should estimate the effect of the rating on the topics, right? So right here, we want to specify that we want to analyze the relationship between all 10 topics and the rating. And then we use the trained STM model for analysis. We connect the metadata to the topic analysis, and we adjust some statistical uncertainty right here. Right. Let's run the effects estimation. And after that, we can plot the effect estimation which is run. So right here, how you interpret the meaning of this plot. Okay, so there's only one thing in this plot I want to specify is the covariate value 1 equal to 4.5 and the covariate value 2 equal to 3. Why is that? Okay, let me show you the distribution of the rating column. So you see the rating column, the minimum value is 2 and the maximum value is 4.5. So based on this context, I want to tell R that if any review with the rating smaller than 3, so that is the low rating, and any value from 3 to 4.5, that is high rating. All right, good. Now let's run the plot. We'll rerun it. And right here is what we have. So on the x-axis, that is the coefficients of the rating. It's ranged from minus 0.4 to 0.4. All right. On the y-axis, you have the topics from 1 to 10. Then how would you interpret it? Now let's focus on topic number 9. You see topic number 9 is quite highly associated with the low rating. On the other hand, topic number 6 is quite highly associated with the high rating, right? Good. Now we can try a little bit with the word cloud for topic 9, topic 6 to see if we can get any insight. All right, so if you look at the word cloud of topic number 9, as a marketing manager, as a marketing specialist, what's your insight? All right. It's quite challenging. It might be not that obvious, right? And let's do the same for topic 6. All right. So it's somehow still confusing. So it's not like straightforward enough. The other way around, we can check the whole summary result of SDM model. Okay, so the model is set to extract the 10 distinct topics from the guest preview, right? And the total number of previews processed in the model was 420. The model identified 2,138 unique words in a dataset after pre-processing, right? And for each topic, there are 4 parameters that we need to consider, right? So the first parameter is the highest prob. What does it mean? That is the most likely words for each topic. Those are words that have the highest probability of appearing in a topic. The second parameter is FRET. What is that? That is the frequency exclusivity. Those are words that distinguish the topic. The words appear frequently in a topic, but are also very unique to it compared to other topics, right? And the next parameter is lived. So it means rare but important words. Those are words are not the most frequent, but highly associated with the topic. And we have another parameter is score. This is the best combination of predictive words. This metric combines probability and uniqueness to select words that best represent the topic overall. All right, now let's come back to topic 9. Now you can focus on the result model, and even you can check with the word cloud as well. So what do you think? What we have? What is the insight we can generate for our company? All right. So if we only look at the highest probability words, so we see place, get, bet, stay, location, apart, like. Is it helpful? It's very similar to the word cloud, right? Apart, like, get, right? How about we look at the second parameter? The second parameter is the frequency exclusivity. Those words make the topic is so unique compared to other topics. So we see the bug, and, seam, guide, wall, review, heart. All right. Or even we can look at the third parameter, lift. So we see judge, somebody, awkward, balance, brutal. What do you think? All right. So maybe we see some emotional feelings of customer like awkward, like feel brutal, judgmental, because they face to some situation about the bug, about the war, about the place, about the bad. And remember, when we analyze the topic 9, we should keep in mind that topic 9 is quite highly associated with low rating, right? So it might be there's some negative feeling about the hygiene, about the cleanliness issue in the property that customer rented in this region of the city. All right. And as a marketing specialist, you need to come up with those solutions to take care of those issues for your customer. All right. Now let's do the same very quickly for topic number 6. All right. So topic number 6 very highly associated with positive ratings, right? And we can look at the workout here, and we also should look at the model result right here. So we have the highest brought words such as nice, stay. Nice day could be the theme for this topic, right? And if we look at the second barometer, which make the topic unique, like friendly, like nice, welcoming, flexible, maybe the guests appreciated the host who are very welcoming, who are very flexible because they have a nice day, they have comfortable stay. That might be the insight that we want to generate for the company. That could be the hidden theme for this topic. All right. So again, always try to generate an insight from your analysis. Great. Now, so far, we just look at the relationship between the rating and the topic, but we didn't look at the topic probability. So it's time to do it now. So we can compute the topic probability by extract the data from SDM model, right? And then we can compute the average topic probability for all the topics, all right? And then we can visualize it. Okay, what do you think? If you look at this plot, will you change your mind? Will topic 6 and 9 will be the most important one, or you want to analyze something else? So right here, you see the topic 6 has the highest average probability. So yes, topic 6 is very important one to analyze. All right. So you might want to analyze topic 2 as well because it has second highest average probability, right? And now let's look at the relationship plot. So topic 2 is also very highly related to high rating. So if you analyze topic 2, keep that in mind that the insight should be related to high rating. Okay, I would like to show you the last step just for verification. We say topic 9 could be something about the bug, about the hygiene, about the cleanliness problem, right? The idea is we can assign a dominant topic for each document. Then we can read the document of the review itself and see if our justification makes sense or not. Okay, so let's run the code. Okay, and now let's open the data frame. And so let's go to topic 9 and let's choose one of the comments or review and we read and we justify whether our justification so far makes sense or not. All right. Okay, let's choose this one. So this one was very problematic. When I came, I couldn't get in and I slept in the neighbor couch. And the linens were not cleaned. But the host tried her best to compensate me. So it totally makes sense. The hidden topic 9 is about the hygiene, about the cleanliness. All right. So we did a good job. Of course, so far I just show you very basic analysis of sentiment analysis and topic modeling, and you always can improve it much further. Hi everyone, today we are diving into image analytics using R and we will go step by step from loading the image, training the model, and finally analyzing the result. Now let's get started. Before we do any deep learning, we have to set up our environment. I have prepared a setup guide for you for both Mac user and for Windows users. Because I am on my Mac right now, so my illustration mostly use the setup guide for Mac. All right, so let's do it. So you can download the setup guide using the link in the video descriptions. And I also show the description on the screen right now, just for your preference. And let's do it now on the terminal. All right, just a note that you might want to consider to install the Python version 3.11 that will work stably with all the packages required for our analysis today. So just in case, if you look at the screen right now, because I already installed the Python, so I don't need to reinstall that. Just in case if you didn't install any Python before, so just go ahead and install the software. Next, I will create a virtual environment. And then I will activate that virtual environment. So the virtual environment here named R TensorFloat. And now it's time for me to install the TensorFloat. Okay, why we need to do this? Deep learning in R relies on a package called Keras, but it actually uses Python and TensorFlow to do the heavy lifting. So we need to make sure R can talk to Python and use the TensorFlow library. All right, now we are ready to tell R to use a specific Python environment where the TensorFlow is installed. All right. Okay, so first we need to use the package reticulate. And you can install the package and just run it once because I already installed, so I don't need to reinstall the package. I just call the package. Now I will tell R to use the virtual environment where the TensorFlow is installed. Now I will check which Python version and the libraries that our R is using. Excellent. So you see the Python version 3.11 was installed and the TensorFlow package was also successfully installed. Now we can call the library TensorFlow. Good. And now we will test if the TensorFlow is installed correctly and can access our central processing unit or not by running this code. Excellent. If you see a notification like this one, it means that you already installed TensorFlow successfully into the virtual environment, and this library can access our central processing unit. Now our environment is ready. So let's install and load the R packages that we use throughout our analysis today. So packages in R, like the language modular, like you need to plug in the tools that you need for the job. In particular, we have several important packages like Keras, like EB image. Okay, so you can run everything in this step at once because the way it is written to avoid reinstall the existing package and you only install the missing package. So it's safe to run all the codes here at once. Great. Now let's move on to the second step. We load our image metadata. Before we start working with the actual image, we need to load a file that contains metadata for each image. In particular, in this case, we need an Excel file that includes all the useful information like whether the image has a human in it or not, whether it shows a logo clearly or whether it's colorful, and so on. This data will help us later on when we try to understand what makes an image popular. Now, let's open the file. Okay, so let's just have a quick look at the file we just uploaded. So you have the first column, you have the image ID. The second column, you have the classification, whether the image is popular or not. The next column, whether the image is colorful or not. The next column, whether we have a human in the image or not, whether the logo is shown clearly or not, and whether the product itself is shown clearly in the image or not. Great. All right, so now we can look at a couple of images from our dataset. One popular image and another one is an unpopular image. This will help us understand what the model will be seeing. All right. Of course, we will use a lot of more image later on, but it's good to inspect a few first. All right. So if you look at this image, it's quite clearly the logo is shown in the image, right? And this is classified as popular. Now, if you look at this image, it's a little bit busy, so a lot of things there. And this image is classified as unpopular. And again, the deep learning model can look at thousands of images at the same time, but our human brain can learn a lot just by looking at one like we just did. Now let's move to step number 4. We need to load all the images that we have. In particular, here in this case, we have 20 images, 10 popular and 10 unpopular. And we need to split them into the training and test sets. Okay, before we moving on, I need to explain to you a little bit regarding the data division into training set and test set. What are they? All right, if you look at the image shown on the screen right now, so you will see the data is divided into different parts, right? When training a model, we don't just use all of our data at once. Instead, we divide it into 3 key parts: training, validation, and test sets. So what is the training? Training data is the largest part. This is what the model actually learns from to understand the patterns in our data, right? Next to the training, we have validation set. This is a smaller portion of the training set used during the training to fine-tune the model hyperparameters, like the learning rate, like number of layers, like the dropout rate. And it helps us decide when to stop training and avoid the overfitting. Good. Once the model is fully trained and tuned, we use the test data. This is a completely untouched data set to evaluate how well the model performs on new unseen observations. And this gives us a realistic idea of how it would behave in the real world. In short, training data teach the model, validation data tunes the model, and testing data evaluate the model. All right, so right now we need to load all the image that we have. Basically, we will create a vector that store the name of the image file that we have in our folder. So in the first 10 are the 10 popular image, and another 10 are unpopular image. That's it. And the vector will look something like this one, like 1, 2, 3, 10. And the first 10 here are the popular image, and starting from 11th, 12, and so on until 20. So the second half will be unpopular image. That's it. Great. So we have the vector. Now we just load all the image that we have into that list. Good. Now it's time for us to divide the data into training and test sets. So in the training set, we will keep a popular image and 8 unpopular image. And in the test set, we will keep 2 popular image and 2 unpopular image. Let's run the code. All right, and we also need to resize all the image to 400 by 400 pixels because deep learning models need image to be the same size. Okay, this idea is very simple. Imagine trying to train a model where some images are very huge and others are tiny. It wouldn't work well, right? So let's do it. Now let's have a look at how training set look like. Great. And here is how the test sets looks like. Excellent. In step 5, we need to create the label for classifications. Popular image will get a label of 1 and unpopular image will get a label of 0. And these are we call binary classification labels. All right, so right here we create the label for the training set. Right here we create the label for the test set. And because the deep learning model in R relies on the Keras package, so it is important we need to install the Keras package to the virtual environment we created in the beginning. So you need to run this step. So in this case, because I already installed Keras, so right here it responds that Keras is available and ready to use. But for your case, you might see the Keras package is being installed, right? And after we have the label for popular image and unpopular ones, we need to convert those labels into a format that our deep learning model can work with, what we call categorical labels. All right, so let's build our model. We are using a type of neural network called a convolutional neural network, or CNN for short. And CNN models are really good at analyzing the image. They work by scanning the small parts of the image at a time, kind of like how your eyes scan a photo. All right, so let's start to explain the idea of CNN a little bit. If you look at the architecture diagram of CNN on the screen right now, you will see first we have the input layer. Basically, input layers are all the images entering the network as a matrix of B-cell values. And after that, we have a convolution layer. So multiple filters slide or scan over the image and will detect the patterns like edge, textures, and shapes. This is where the model begins to learn the visual features. And after the convolution layer, we have the pooling layer. This layer reduces the size of the feature maps while keeping the most important information. It's helped to make the model learning faster and more efficient. After pooling layer, we have fully connected layer. This layer will flatten all the pool features and connect all of them together. This layer acts like a traditional neural network. And last but not least, we have the output layer. And this layer will produce the final classification result. And in this case, it might be predicting whether an image is popular or unpopular. All right. So I already prepared the note for every single live code. So please take some time to read as you need. And right here, we only need to run the model itself. Okay, step 7 is quite interesting. This step like putting all the photos into a neat, organized album before showing them to a teacher, right? So before we train the model, we need to reshape the image data again into the format that the CNN model expects. So basically, CNN model expects all the image in a 4D array, including width, height, color channels, and the number of image. And we do this using the aburn function. So let's do it. All right, here we are. Now step 8, training the model. So in this model, we run 30 rounds of learning from the training data. And we also use the validation split. So we can monitor how well the model is learning and if it's starting to overfit. So let's train the model. Okay, it might take a while and then we can analyze the result. All right, so based on this result, what do we see? So the top of the plot, it shows the training loss and the validation loss. Okay, so the training loss is in blue color. It decreased consistently and stabilized around 0.5, which is typically a good sign. And then the validation loss in green. It behaved differently. It stayed relatively high and increased over time and spiking after around the 10th round, right? And the other bottom of the plot, it shows the accuracy of the training set and the validation set. The training accuracy improved rapidly and reached nearly 100% around 10 rounds of training. It shows the model is memorizing training the data. Why? For the validation accuracy remains stuck around 0.25% throughout the entire training process, which is very low. And this confirms the model is not generalizing at all. It is overfitting significantly. So of course, in reality, it's quite common. And you need to do something else. For instance, simplify the model, reduce the layers, like adding the new data. Remember, the data set for this case is only 20 images. It's quite little. And of course, right here, I show you another way to plot the result of the model. Okay, and the interpretation is still the same. All right, step 9, evaluate the model on the training set. It means that we test the model on the same data it trained on. So we will check its predictions, calculate accuracy, and rare confusion metric to see how often it got things right or wrong. Okay, so before we move on, let me explain a little bit on confusion metric. All right, as you can see on the screen right now, that is what we call confusion metric. It is a powerful way to evaluate how well your classification model is doing, especially for binary classification problems, like predicting whether an image is popular or not. So you see the rows represent the predicted classes, what the model thinks, and the column represent for the actual, the true classes. Therefore, possible outcome, TP, true positive. The model predicted positive and it was actually positive. For example, it predicted the image is popular and the image is really is. FP, false positive. The model predicted positive, but it was actually negative. It thought the image was popular, but the image wasn't. And then we have FN, false negative. It means the model predicted negative, but it was actually positive. So basically the algorithm missed a popular image. And we have TN, true negative. The model predicted negative and it was really negative. It correctly identified a popular image. So this metrics give a deeper look than the accuracy index alone. It's help you understand how the model is right or wrong. Okay, so right here, I will compute the accuracy on the training set. So you see the accuracy is 81%. So high training accuracy is great, but we also need to check the test accuracy to see if the model really performed well on the future observations or not. Okay, and this lab code help you to predict the class probability. Basically, we are computing the probability for class popular and class unpopular. Right. And if the probability is larger than 0.5, the label will be 1, and vice versa. All right, and right here, we will show what confusion metric we have. Okay, so again, here is what we just computed, the probability for each image. And here is the predicted class, what the model think. And here's the actual class, what is the true class of each image, right? So the simple confusion matrix will look like this one. You need to analyze what 5 means, what 8 means. But I will show you another advanced technique how to illustrate the confusion matrix by using ggplot, right? Okay, if you look at this confusion matrix, it means that the model have 8 times correctly identify popular image as popular, and the model have 5 times correctly identify unpopular image as unpopular. And right here, I will show you how to compute the accuracy more manually. So basically, we take all the time the model correctly identify the image divided by the sample size of the training set. So we have 13 divided by 16, which is 81.25%. Right. All right, now the real test. Let's see how well the model performs on the new image it has never seen. We need to calculate the test accuracy, look at predictions, and build another confusion matrix. All right, so let's do it. Everything's the same. Basically, we just rerun the analysis on the test set. All right, so what do we have here? So basically, looking at this confusion metric, the model only have 2 times correctly popular image as popular. All right, and the accuracy is 50%. All right. So again, the test accuracy tells us whether the model is learning the real patterns or just memorizing the training image. And of course, when you practice with deep learning or image analytics, you will know we have many ways to improve this kinds of test accuracy. All right, so far we know the future image will be popular and unpopular if we use the training model. But we also want to know whether these popular image have certain features in common, whether unpopular image have certain features in common, and that is what we are going to do in step 11. First, we need to select the image predicted to be popular based on the test set analysis result, right? Remember, in the metadata, we have the last 4 columns are the metadata for each image. We need to extract those informations. And last but not least, let's use the simple plotting functions to tell a story. All right. So again, this step will help us to interpret what the model may have learned about popularity or unpopularity. Reporting the accuracy is good, but it's not enough. We need to use deep learning to tell a story, to inform a managerial decision for the company. That is even more important. How you run the algorithm. So if you look at this result, what is your story? How will you help your company? based on image analytics, using image analytics. All right. So right here, based on this result, if you are the marketing specialist, what will you inform the decision for your future marketing campaigns? So in the test set right here, the model likely never see the grayscale image, it only see the colorful image, which means the colorful image might be good for, for your future campaigns or promotion campaigns. Interestingly, all images are not human-centric will be identified as popular, including a human subject in your shooting campaigns may not be that useful as you thought. And right here, on the image, have a logo exposure. So if logo present is a key factor, the model will predict the future image as popular. Right here, if you have some variation for product exposure. And again, I just use tiny data set to illustrate how to do image analytics. The model might be overfitting because it doesn't have enough data to generalize for the future data. So if you start your image analytics project, it might be brilliant to collect more data as you could. Right, and that's it. We just built and evaluated our first image classification model using deep learning in R. And feel free to pause, rewatch the video, and try the analysis with your own dataset. Good luck.